Thank you for joining us today. I will be presenting High Performance Can Inspection. Pico Inspex has been a story of continuous development and innovation, partly because of our location here in the Silicon Valley, however, more importantly, because of the people that built this company and those who drive it today. I will tell you about a few of the developments and innovations we have made in high performance can inspection, but also let you know that the best is still in the making, because what drives us is continuing to set Pico Inspex apart from any other competitor and to provide our customers with the best solutions and service possible. The most important development and innovation achievement was our initial X-ray platform. This was and is the foundation on which we continue to expand in beer and beverage inspection, pioneering the use of multiple beams, launching our new ScanTrack Shield product line, and most recently introducing a new high-resolution imaging system. Pico Inspex began its journey into full container X-ray inspection in 1998. Over a 3-year period, we developed an X-ray technology platform that would transform the industry and X-ray performance expectations. When we embarked on this investment, we knew the challenges would be significant. First, the speed of canning lines, running up to 1,000 containers per minute back to back, would require new and extremely rapid detection and algorithmic computations never before seen in the food industry. Next, the power of the X-ray required to penetrate both the metal containers and the product in the container. The power needed would be on a level never before seen in the food industry. Another challenge would be building a compact unit that could fit into existing customer conveyor lines. And finally, our customers would be located around the globe, so we would need to have online access to all machines in order to service customers. It was with these ambitious goals and challenges that Pico Inspex set out to develop the most state-of-the-art X-ray inspection system in the industry. We introduced the ScanTrack Solo X-ray inspection system in 2002. In this process, we achieved all of our goals and then some. First, the speed and power. We developed the software and algorithms capable of processing image between 1 and 5 milliseconds, thereby attaining our 1,000 containers per minute goal. And the power source we developed provided the clearest and best images in the industry, even at 1,000 containers per minute. Even today, in head-to-head comparisons, we amaze our customers by finding foreign material in containers other competitors simply cannot detect. And finally, we adapted our ScanTrack Solo with online access, so whether our customers are down the road in California or across the oceans, we can provide the fastest and best service possible. Simply put, when we go online with customers, we see what they see. While we achieve the X-ray speed, power, line placement, and online monitoring we desired, perhaps the most important advancement was in a new concept we brought to X-ray detection. That is the learned container versus the masked container. The first image on this slide demonstrates how Pico Inspex technology learns the container, including the difficult to inspect side seam and the top and bottom seams. By doing this learn, we are able to reduce false rejects caused by these difficult to inspect aspects of a container. The next image is the process of masking those parts of the container. By doing this, our competitors reduce false reject caused by these areas. However, as a consequence, our competition does not achieve a full container inspection. Further technology advances were next achieved with the speed of our systems. With the new computing speeds being introduced by our neighbors in the Silicon Valley, we increased our computing capability and speeds. This enabled us to offer solutions in X-ray detection to the beer and beverage industry, which operate at speeds much higher than the food industry. Glass bottle detection systems are available, as you can see in this video, at speeds up to 1,400 bottles per minute. And can X-ray detection systems are available at speeds up to 2,200 cans per minute. In addition to finding foreign material at these speeds, our machines also detect container imperfections, fill height, missing or broken vent tubes, and provide filler monitoring. Today, we remain the only X-ray inspection company that can offer solutions to the beer and beverage industry at these speeds. Next, Pico Inspex pioneered the first use of multiple beams in the inspection of containers. By adding a beam to the existing ScanTrack Solo, we could expand the size containers to be inspected, including number 10 cans. We call this unit the ScanTrack Crescendo. The first picture depicts just a sample of products upon which we can provide full container X-ray inspection. The video then demonstrates first the typical Scantrack Solo beam inspecting most of the container. The second beam captures an image in the upper section of the container, so full container detection can be achieved. To image large containers, competitive systems rely on a single X-ray beam with a very long focal point, which means dramatically less imaging power and much lower detection capability. The next development, the use of 3 beams for inspection. Since we had been successful in integrating 2-beam technology, we moved on to our next development, a 3-beam system we call the Scantrack Trio. As you can see from the rendition to the right, the Trio leverages 3 X-ray beams powered from a single X-ray tube to provide 3 individual looks at each container. This allows optimal detection of asymmetric pieces of foreign materials such as glass shards, metal shavings and strands, and bones. Objects that were not able to be detected before because of their different shapes are now reliably detected. Today we have long-time Scantrack Solo customers making the switch in their canning operations to the Scantrack Trio, this to provide the extra protection offered. We began the next development project for the overall Scantrack product line in 2015, as we updated the entire infrastructure of our technology. We introduced the Scantrack Shield product line in 2018. This new Shield system retains the core speed and imaging capabilities that make Pico Inspex the X-ray system of choice. With the new componentry employed in the Shield, we were able to achieve a 20% improvement in detection capability for most contaminant types. The Shield technology upgrade made further improvements to its high reliability architecture to ensure that machines keep running even under the harshest conditions. In 2019, we introduced a new higher resolution imaging technology we refer to as HRX. This next image is our high resolution image. The difference in the clarity and quality of the 2 images can easily be seen. In addition to better data processing, enhanced X-ray imaging now yields more highly resolved images using techniques such as our high-res diode arrays. These higher resolution systems can be incorporated into our side view can inspection lines such as the Solo, Crescendo, and Trio, greatly reducing the size of contaminants we can find and eject. I hope you have been able to detect that Pico Inspex is all about technology and its further and continued development, all in support of our customers. If you are a current customer, thank you. If you are a potential future customer, let me and our team assure you that contacting us to understand what we can do for you will be well worth the effort. Thank you.
The question is, can X-ray detect pull tab or pull ring on a can?
Well, I'll kind of rephrase the response. As we're taking a picture, if the ring pulls in the picture, we can certainly determine if it's there. You know, sometimes the container may be, I'm not talking about beverage containers, but food containers in particular, may be conveyed, with the ring pull easy open end down. And in which case, that becomes more problematic. And there's a good reason usually why we're inspecting with the ring pull down. But if it's in the image, yeah, it's made of metal. It's very likely to be detected and confirmed that it's there. For some of the beverage applications as well, you may want to be looking and see whether it's misplaced. You know, a pop-up ring pull can be a problem downstream when you get into multi-packing applications. So we can detect ring pulls that are not properly close to the top of the lid.
I've got another question on headspace. What sort of accuracy can X-ray detect headspace and to what volume?
I think we can do quite well. In fact, it's been an interesting development from the product that Ken elucidated on, that Crescendo, we call it, which has a separate beam that goes up to the top of the container, then scans down. It was designed to make sure we got a really good image of the top of the big cans in particular, but to actually have customers who are using the Crescendo to work with fairly normal diameter containers just to confirm the accuracy of the image at the top. Now, they are in particular are interested in the seam, because they get a very, very good view of the seam, but the same thing would apply to the headspace. Overall, the headspace is in the image, whether it's a single beam or a dual beam. And in terms of the resolution, it's certainly going to beat, the requirements for companies that are trying to maintain a 1/4 of an inch or 3/8 of an inch headspace in the top of a container. And that's one of the great applications for X-ray on food cans, is that we can do it 100% of the time, as opposed to the current ways that companies employ to confirm that they're meeting their headspace requirements, which is by sampling.
So next question would be around track and trace functionality of X-ray? What sort of things can you offer in the canning book?
Well, increasingly, things are getting marked. It's kind of a product of the demands of the marketplace, for track and trace, but also in the contaminant inspection. One of the things has been the marking of the cans at the discharge of the seamer to make sure that when the label goes on, it's matching up what they put the product in that can at that point. And we've incorporated some of those advances into utilizing a high-speed marking system to mark the can if it's been signaled for a reject or for any other purpose. So we get a kind of a double, we're going to reject it in most cases, but it's also a marker for us just to use just in case, for whatever reason, it may make its way downstream and still be in the product flow before it gets multi-packed.
The other thing we're looking at, and I don't know if any of the reviewers saw Jay's off Industry 4.0, but more and more customers are talking to us about the ability to match a picture that we take with the container itself, mark the container, understand, you keep that on file so that months later, perhaps you can match it back to if anything happens downstream. So we're having more and more of those discussions with customers.
Last question, what about dents? What kind of applications are you seeing in dent detection?
Well, I can. I mean, dents, it's a double-edged sword, isn't it? Because there's kind of like good dents and bad dents. And X-ray, if you just set it up for foreign material detection, a dent, when it appears in the image, is going to look like a piece of foreign material until we eject it. And so you get into that conflict. Well, some of those dents are too small. We're going to put a label on them. So we've been, developing, our skills so that we can match what your desires are. And one of those is through the use of our multi-beam trio system, allows us to really get a good view of the sides of the whole circumference of the can. And so if you want the dents to be detected, we can detect. Similarly, if there's a certain tolerance level that you have for dents, they can be basically excluded from the classification as a piece of foreign material. And this is how X-ray has evolved from very beginning when we started this some 20 years ago to where we are today. We're increasingly more sophisticated and be able to discriminate what's good and what's bad.
Thank you very much.